I'm happy to see a couple of things this morning. Number one, that there's more people in the audience than there are on the panel, so that's already a good morning. Second thing is, I'd like to thank AFCEA and IEEE for their support of this activity and their invitation for the Joint Tactical Networking Center, PEO C3T of the Army, and the Communications and Electronics Research and Development Center to come out and spend about an hour with you fine folks to talk latest waveform developments. As most of you know, soldiers, airmen, and Marines rely on today's manpack and platform radios to provide much more than voice communications. We need to begin to think of these radios in effect as many highly capable computers, which are heavily reliant, which has been a theme of this entire MILCOM conference over the last 3 days, on software, specifically software waveforms that enable voice, data, chat functionality, and situational awareness capability that, frankly, today's service members rely on. All you have to do is go to any combat training center rotation and see how these kids communicate nowadays. They're not talking a whole lot over voice. They're doing a whole lot of chat. Waveforms enable that functionality. In this panel, Defense Department and Army officials will provide an update regarding ongoing waveform status, DoD waveform IR additions, and advancements in new waveform developments and capabilities. We have 3 officials today from the Joint Tactical Networking Center in San Diego, California, the Army Program Executive Office C3T at Aberdeen Proving Ground, Maryland, and the Army's Communications and Electronics Research and Development Center, say that 3 times fast, also at Aberdeen Proving Ground, Maryland. Mr. Jeff Mercer is the director of the Joint Tactical Networking Center in San Diego, California. He is responsible for the Department of Defense waveform standards, waveform compliance, certification analysis, and the DoD Waveform Information Repository. Mr. Shawn Matthews, who's going to get all of the difficult questions because he is a cyber engineer from the Product Manager Tactical Waveforms, or Tactical Radios, PDM Waveforms out of Aberdeen Proving Ground, Maryland. Shawn is a member of the PDM Waveform Systems Engineering staff, responsible for RF resiliency, spectrum supportability, and waveform synchronization planning, which means he's much better educated than I ever thought of being. And last but not least, Dr. Derya Cansever from the U.S. Army Communications Electronics Research Development Engineering Center. Dr. Cansever is the technical leader and contributor to several R&D projects involving tactical networks and waveforms. He also works on fundamental research problems in the areas of network science, cyber computing engineering, and it is in close collaboration with the Army Research Laboratory. He earned his PhD in electrical computer engineering from the University of Illinois, which my Michigan State Spartans will beat in football this year, which will be the only team they may beat this year, but it will happen. And with that, Mr. Mercer, the panel's yours.
Hey, great. Good morning, everybody, and thanks, Paul. Appreciate it. And also, I want to echo Paul's comments as far as thanks to AFCEA, IEEE for putting on this special event over here. It's great to have our Department of Defense folks in uniform, as well as our industry partners here, vendors from all over the place, as well as folks from academia that are visiting and stuff. So this is a great forum. Had the opportunity to attend a few of the MILCOM conferences over the year, both here in Baltimore as well as San Jose, and it's a wonderful opportunity to get the collective minds together and talk about the importance of things like waveforms. And I got to tell you, I don't think you can start the discussion regarding waveforms without really sort of saying what waveforms are, because in my experience, when you talk waveforms, if you're talking to an engineer and you say, well, a waveform is a electronic signal in space, and their eyes will light up, they'll know what you're talking about. If you talk to an acquisition person regarding a waveform, they'll look at you sort of strange and wonder, what in the heck are you talking about? So when we talk waveforms, if you think about a waveform as that entire set of radio and or communications functions from the user input or that user interface all the way through the RF output and vice versa, essentially everything in the box. I think that brings home the importance of what waveforms are in our communications world, and specifically in the software-defined radio spectrum today and stuff. So I hope, sort of setting that up initially, my partners here are going to talk about more what we're doing in that waveform development process. What I want to do for you today is talk more about how the Joint Tactical Networking Center enables those that are developing as well as sustaining waveforms for the Department of Defense. And it's in the context of the importance of a waveform that the Joint Tactical Networking Center was first envisioned a few years ago and then chartered in around January of 2014 by Mr. Kendall, our ATNL, for Department of Defense. And he had the foresight, knowing the importance of the waveform and what it was going to mean for communications for the future, to have an organization stood up that specifically enabled help developers in developing waveforms, but also helped establish the standards from which those waveforms would be developed. And of course, there's a lot of good reasons, which we'll talk about here in a bit, for why we do that. But the JTNC has roughly 4 core functions that were assigned to it and a number of non-core functions that we actually deal with. Those 4 core functions, 3 of which I think Paul alluded to earlier, include developing and evolving the standards for software-defined radios, for waveforms out there. And that's an important, increasingly important job out there, and something, quite frankly, as we move into the open systems architecture, open systems approach, we have to really pay attention to standards, and we all have to be on the same page as we deal with standards. A second core function that Paul alluded to was maintaining the DoD's waveform information repository. This is a secure repository that the DoD is safeguarding its multi-billion-dollar investment in the waveform business in. And we're doing that for a couple of reasons. Obviously, one is the safeguarding of this huge investment that DoD continues to make in waveforms, but also, and I think more importantly, it's in this open systems architecture environment and sharing environment that we want to have a repository where folks, both government as well as industry, can pull from to help them to, number one, reduce redundancy out there in developments, but also to help facilitate bringing new technology back to the government and stuff. And so make it a little bit, hopefully, cheaper, faster, by pulling some of the work that's already been done, taking a look at that and seeing how we might be able to improve it and then bring it back to the government. The next role that we have, our core function, is to be experts on waveforms, and specifically to do technical analyses of waveforms as they relate to interoperability, security, affordability, and exportability considerations out there. And we look at waveforms as an independent agency out there. We don't have bias one way or the other to the developer. We are most interested in ferreting out things that we see in those waveforms where we can make improvements, make recommendations to developers to take those waveforms and ultimately improve them in the future. We also look at the products of which those waveforms actually are ported to or instantiated on, and look at those from a compliance and certification perspective. And lastly, I think one of the more important roles that we're starting to play in this business is being a technical advisor to a Department of Defense Board of Directors, headed up by Mr. Kendall, Mr. Halverson, the DoD CIO, and the acquisition executives for each of the services out there. A technical advisor in the software-defined radio and waveform area out there. And what the last thing I'm going to cover today, well, I'll talk about a few of the emerging themes or trends that we're seeing as an organization that we think the Department of Defense and others need to pay a little bit more attention to. Next slide. Okay, so before I hit those, I want to just briefly go over some of the highlights of what we've been up to in the JTNC. Specifically, this Department of Defense Waveform Information Repository. One Waveform Information Repository for all DoD waveforms out there. There are a number of DoD waveforms out there, some that are software-defined, others not. We are interested primarily in the software-defined waveforms, putting those into a repository, a secure repository, and making those available to everybody out there. When we talk about the process, if you will, of this DoD, putting something in the DoD waveform IR, we're going through an extensive process of ensuring that what we take in is clean. Essentially, we've done the virus, the malware checks, and then I think most importantly, we're collecting, assembling all of the artifacts, the technical artifacts, to include the source code of these waveforms, putting it all together, cataloging it so it's easy access for folks to retrieve. We've done about 17 right now. There's about 17 catalog waveforms in the IR. There are probably close to 100, anywhere from 84 to 100 waveforms that we're looking at right now within the Department of Defense. Not all of those will ultimately make it in the IR. That's yet to be determined as we work out who those waveform sponsors are, which services are sponsors for various waveforms. But we have a lot of work to do. That catalog of waveforms is increasing weekly. I've got about probably 9 or 10 waveforms that are sitting in a queue right now for us to process into the information repository before we get to the next group of waveforms that will ultimately make it here. I mentioned we do technical analysis of the waveforms. So we've done extensive analysis now on 5 waveforms. These are relatively new waveforms out there. Of course, you've heard of Soldier Radio Waveform, wideband networking waveform, W&W, MUOS, of course, which is very popular out there right now. We're finishing up a technical analysis today on the Navy's Link 16 waveform, and we're starting a process right now on the Army's H&W version 3.0 waveform. The next thing, as I mentioned earlier, that we're dealing with is standards and the importance of standards. And we've been very busy in the standards evolvement area. In fact, the standards that we, as well as the specifications that we are developing, ultimately are stored in DISA's Defense Information Technology Standards Registry, or the DISR. Those are both emerging as well as mandated standards. There's also some informational guidance type of standards or specifications within the DISR. Our big one right now that we've been working is an emerging standard called the Software Communications Architecture version 4.1, which is a backwards compatible standard to a mandated AFCEA version 2.2.2. It provides a lot more cybersecurity benefits, as well as a number of other benefits, and we're excited about this one. It is an emerging standard today in the DISR, and we expect it to be a mandated standard, hopefully in the 17 timeframe. Our focus for FY17 is to continue to do more technical analyses out there. We will continue to evolve the standards, as well as we're going to continue improving the Defense Waveform Information Repository, which we hope will benefit all of you. Next slide, please. Okay, as far as emergent themes, what are we seeing out there? Well, we've had now 5 technical analyses under our belt, and there's a number of things. I'm going to touch on 4 of them right here. The first one being the need for more emphasis on electronic protection when developing waveforms. We spend, obviously, as I mentioned, a lot of money on the waveform business. And this is crucial communications for our warfighters out there. What we're seeing is we're not spending enough time doing the work up front on our intelligence, on possible threats out there before we develop the waveforms. And we need to look at those type of things early on before we get into the development process. That requires changes. It requires changes as well as resources. It requires changes in DoD guidance out there, things like 5002, that DoD instruction. And it also requires that programs be resourced appropriately so that they will take electronic protection, make it a priority right up front. Cybersecurity. You can't go to any meeting or have discussions anywhere without talking cybersecurity. And if you had the opportunity yesterday at the keynote address at lunchtime, General Earl Matthews got up and spoke about cybersecurity and the need for, obviously, increased emphasis on cybersecurity. That is very apparent in the waveform business, too. A lot of the security type of controls, the various policies and stuff that we have in place today date back to the early 2000s. And they haven't kept pace with the change in technology as well as the threats out there. And so there are gaps in security that we have to close as it relates to our waveform developments. Open systems architecture and standards. We are trying to do our part to help facilitate this really beneficial environment that we're in of dealing very closely with industry, government, our international partners in evolving standards and this open systems architecture out there. We've been providing, we actually published recently a open standards architecture procurement guide for our government program managers, which has recommended wording that they can put in RFPs, RFIs out there that will ask for the right things from industry as it relates to open system standards and architectures out there. Exportability considerations. Weekly, we are now in the Department of Defense getting requests from our coalition partners, international friends, to share source code as it relates to waveforms out there. And this is a complex issue, technology protection issue, and something that the department hasn't come to grasp with yet as it relates to policy. And so the department has been working hard for some time, I will say, on export policy. I hope that we will see a draft of export policy covering waveform source code maybe by December of 17. But the issue's being worked hard. And right now, what we would like to see is export considerations considered right up front, once again, like electronic protection in the development of waveforms. Program managers need to consider that earlier. And that's going to require changes, once again, to DoD issuances out there, things like 5002, that guide the acquisition community and program managers. It will also possibly impact the resources that they need to consider these export considerations up front. So we're working hard with the folks in the Department of Defense to deal with this particular issue, and I hope that we'll have an answer soon to that for the next requests that come in. So with that, I'm going to go ahead and turn this over to Shawn Matthews of PM Tactical Radios. Shawn.
Thank you very much. I'm going to give you a fairly brief introduction today into our plans for developing and releasing the next generation of waveforms that are going to be fielded into our hardware platforms and handed to our soldiers. Most people in this crowd are very familiar in the evolution of software-defined radios as we've gone from hardware-based radio implementations into basically a first generation of SDRs that were very vendor-specific, not necessarily interoperable, not well controlled by the government, into a state where we are today, where the government builds these waveforms that we control and maintain and as Mr. Mercer just described, distribute to vendors. that are interoperable and upgradable over time. So one of the more significant problems we have with the SDR world is that they are so upgradable and so readily changed. So what PMTR is currently migrating to is a very rigorous, time-blocked schedule that synchronizes waveform development and distribution along with the platform procurement, porting, integration, and test activities. Take the next slide, please. So graphically, you can see the synchronization. Currently, it's planned for major waveform development and distribution to be released on a 4-year cycle. That will allow us to do our plan our procurements, knowing that every 4 years you're going to have major upgrades to your waveform products that will have to be ported onto all hardware platforms. Over that 4 years before the next waveform is dropped, any upgrades that happen will ensure interoperability and backwards compatibility so that waveforms that are built or ported in year 1 of that 4-year period will be compatible with waveforms that are ported and fielded in year 4 of that block. They're hopefully alleviating some of the interoperability concerns that we see with radios today. Next, please. So as Mr. Mercer also just discussed, there are a couple of key themes that are a part of each of these of our plans over the next handful of years for our waveform development and enhancement. The first of which is cybersecurity and robustness in a very contested environment. Like you mentioned, you can't go anywhere without talking about threats to our systems, whether it's a cyber threat or an RF-based threat to our radios. We're putting a lot of effort and focus on improving our security and our resiliency in a contested and congested RF environment. The next major thrust that you'll see in a lot of our development is being a better user, a more efficient user of that spectrum. It's a very constrained and very precious resource. And we've got a significant focus at this point in getting more users into the same bandwidth, being more efficient with the data that we push over that pipe, and at the same time trying to meet a commander's intent or commander's need for range and observability as well. Next slide, please. So the question that we get most frequently is how do we get involved in the waveform development and procurement? In December of this year, we are hoping to be able to release an RFP for the follow-on software support contract for PDM waveforms. You can go to FedBizOps to find any information available on that. We had an industry day about a month and a half ago and discussed this with most of our industry partners, so a lot of you may already be familiar with this. But if you're interested in taking part in the waveform enhancement and maintenance activities that PMTR will be conducting over the next 5 to 10 years, that is the vehicle to get in touch with us and to become involved. And I believe that is my last slide, so I'll be turning it over to Dr. Cansever.
Okay, thank you. Okay, so as the R&D arm for Army Communications, we view our role is to help PMTR and JTNC to make sure that the waveforms that are developed are interoperable and easily portable. So not only do we contribute to the development process, as writing code and doing analysis, so on and so forth, but we believe that our primary function also includes to ensuring that those waveforms are of the top quality, interoperable, and easily portable. And it is also our goal to ensure that some of the technologies developed in one waveform updates are easily pluggable into other waveforms. So this is going to make the process easier, much more rapid, and the quality of the waveforms better. To give an idea of what I mean, here is a notional view of how waveform development and updates occur. So, for instance, in the Singar's waveform, there is a timeline in which a ComSec modernization occurs and it is inserted into the waveform. And later on, it's going to be transec modernization and inserted to the waveform. And this is an ongoing process. Same thing occurs with SRW, WNW, and other waveforms. And for which we are going, just the vendors, the academia, and the other participants develop code. It is tested and just inserted in due time. But what we'd like to, what's happen is that something that's developed in one of the waveforms should be more or less applicable to other waveforms, and then the government should be able to leverage what it has funded in one instance of a waveform can be readily reusable in another instance. That's a big goal, but it's going to be done incrementally, and we are trying to help with this process. So that's what I'll be briefly talking about today. So we'd like to get some of the cross-pollination and inter-waveform leverage. Next slide, please. So here is a waveform ecosystem as we view it. We have, I think it's it's an ecosystem that's populated by the industry, by the academia, by the labs, by the user groups, by the maintenance groups. So for one part of it is operations and requirements feedback loop. So any waveform that has been fielded, we do lots of measurements and feedback, and we use it for further updates over time. And we also get new requirements and technical gaps statements from the associated organizations such as CERDEC, and they all are part of the ecosystem for new waveform development and updates. And then this input goes to the over-the-air interface specification, which is maintained by the Waveform Committee, and that's very important. And it is to make sure that any implementation are interoperable. That's what we are striving for. And we would like to go one more step in this process. And we at CERDEC, SNTCD, have a new program where we are developing a reference model for waveform development support, which goes hand in hand with over-the-air interface specification. So what we are coming up with is, using using over-the-counter components and freely available software to build a modular reference model, so that when a vendor or a lab develops a new waveform, it will take its components and make it run on that reference model. And that's going to ensure that if that waveform can run on that reference waveform successfully, the likelihood that it's going to be easily portable will increase exponentially. And this reference hardware will also be supplemented by the waveform development environment that will be made freely available to the community, so that it will have multiple benefits, such as it's going to be a lot, so that the components will be identified easily, and it's going to be easy to plug and play, and it will enhance interoperability, and it will enhance portability. So we are working with that in that direction. So once we build that reference model, we will realize it, using over-the-counter components and make it available. And it will be validated to perform functionality and then to make sure that the over-the-air interfaces are fully interoperable. And we expect that this reference model will be maintained by the Waveform Committee, which is maintaining the over-the-air interface specification. So it's really like one more step for the implementation and testing of over-the-air interface specification. And this will allow all the R&D, all the members of the ecosystem to quickly add features or generate new waveforms. And we think that it's going to reduce the hurdles in transitioning it. And it's going to be a resource for the whole community. Next slide, please. So here is the notional view of the reference hardware that I'm trying to describe. So we have different components, like user data, crypto subsystem, transect system, networking, modem, RF system, so on and so forth. And out of which we will generate some test vectors, and it's going to enable the easier, fast development, interoperability, and portability. And then, so that, and this will allow the producers of waveform to do all the optimizations and secret sources and value added within those components, but to make sure that it is interoperable at that intercomponent level. And that is ongoing work at CERDEC, SNTCD, and we are excited about that, and we hope to deliver it within a year or so.
All right, thank you. And before we open it up to the floor for questions, I'm excited now about waveforms. This is great stuff. So I've got a few questions. First off, is SCA 4.1 a mandated standard?
I'll take that one, Paul, if you don't mind. I mentioned earlier that DISR contains both emerging as well as mandated and informational type of standards or specifications out there. SCA 4.1 is currently an emerging standard out there. Emerging meaning in DISR language out there that it's expected basically to be a mandatory standard within 3 years' time. It's implemented usually on about a minimum of 3 different platforms for us to get experience with, sort of shake it out a little bit. And emerging standards also provide an opportunity for us to get feedback on whether or not that standard is good, we need to make some adjustments to it, et cetera. So SCA 4.1, an emerging standard, going to mandatory here, hopefully in 17.
Thank you. So we just talked a lot about this reference radio tactical model from CERDEC, and since we have a decent amount of industry here in the audience, is that going to be something that's free of charge to industry, or how does industry access
Yeah.
this model once it's available in a year or so?
Yes, we intend to make it free of charge available to the industry, and we will work with the PM for the right processes to make it a possibility. And we are basing the software component of it on Red Hawk, but we will modify it so that it is optimized for tactical waveforms, but it's not limited to that.
All right, thank you. And one last one from me. So you look at software-defined radios, right? It's relatively, argumentably, a new concept to the joint services and certainly the Army. From a sustainment standpoint, I know that we're working through how do we look at maintenance patches? How do we look at opportunities? I guess probably isn't the right word, but how do we begin to institutionalize how we do upgrades to these systems?
Yeah, I'm assuming that one's aimed at me since we are the procurement and fielding side. So a lot of people, when they hear patches to a software product on a device, they start to think of their iPhones, where they plug it in at night, they wake up in the morning, and the update has been applied to whatever application it is that they run. The current state of technology on our fielded radios is not quite there yet. So that was one of the main drivers towards our blocked approach to our waveform development and hardware procurement to ease that process a little bit. Right now, updating and patching of waveforms in hardware platforms is a little touch intensive, so you have to actually have access to the radios. So when you're talking about thousands of radios with units in theater, it's not exactly as easy as an update coming on your ESPN app on your phone or something like that. So limiting the number of times that you have to go out to touch those is one of our major challenges that we're trying to overcome by synchronizing our schedules. And then when you get into radios that run 2 channels, that run 2 waveforms, if you tell them, we've got to go touch that radio twice because we haven't synchronized those schedules, you're going to get a lot of very grumpy PMs looking at you and saying not very nice things. So we are pressing down a path to institutionalize how our waveforms are developed and ported and fielded. And we are also being much more conscious now of maintaining interoperability over a period of time so that the only things that have to be applied are patches, and they're not going to break your functionality with previously fielded versions.
Thank you. So I'm still excited. I know everybody else here is. Who's got questions? Do me a favor. Go use that mic.
Yeah.
They're having a party next door.
Voice is also hoarse from last night.
Go Cubbies.
You mentioned a lot about interoperability. Normally, when I think about in defense context, I think about interoperability with allied forces. Can you define a little bit more about interoperability, either within the joint services or within interoperating between different networks?
So that is a very multi-level question. So there's when I mention interoperability, I'm referring to, say, SRW or W&W version 1.0 versus 2.0. On our schedule, you notice that that first digit rolls every 4 years, and anytime you see that digit roll, you've opened up the opportunity to break backwards interoperability. So SRW2 may not talk to SRW1 any longer. So that is when I keep saying interoperability, that's what I'm referring to in our waveform products. Now, interoperability is maintained across hardware platforms by the fact that SRW2 on a vendor X radio will talk to SRW2 on a vendor Y radio. So we do facilitate interoperability by using those government-controlled waveforms as our communications means. I I think Jeff has quite a bit more experience than I do on how we do this with our partners and what is releasable and what is not. So I'll turn that part of the question over to him.
So it's a great question, and it applies more than just to the joint forces out there. It applies to our coalition partners. Our goal, as you all know, we don't fight as a joint force only. When we go to a fight, we generally fight with our coalition partners out there. So it's not just a single service. It's not just a couple of services within the United States Department of Defense. It's with our coalition partners. And so interoperability is key, and it's not just at the waveform level, it's at the box level also, and stuff. And so one of our huge challenges still today, while we've made inroads in the waveform to waveform interoperability, the boxes within the Department of Defense, within the services, in attaining that interoperability goal, we haven't made as much progress in the coalition environment with the U.S. And so it's an objective that we're still working on right now. I'm confident we're going to find that coalition interoperability solution. We've got to sort of work from the lowest common denominator out there and work up from there. So whether we start with voice and then work our way through data, et cetera, when we talk about interoperability, we're going to get there. It's a tough challenge.
Well, thank you. Anybody else? Yeah, AFCEA actually I think is going to release some of them, but yeah, after this is done, come up and see us. All right. Anybody else? This is a quick panel. I like
You all
this.
are easy. I know you're lagging from last night. I am. I fell asleep
All right,
in the
go-
bottom of the 10th.
Yep.
So
Go get coffee. Oh, there's always this guy. Go ahead.
Going back in history, SCA 2.2 really never touched anything within the modem. It was really kind of a GBP-only interface. They came up with the MHAL for the early jitters radios, which was very unsatisfactory in terms of interfacing the standard, or interfacing the Corba interface into the modem. Does 4.1 do anything different, or is the modem still kind of by itself?
Well, the specifics as far as the modem, I'd have to defer to my technical experts on that one, but I will tell you that we learned a lot out of 2.2.2, and specifically we learned some really rough things, some bad things when we went to 4.0. And also in particular we made 4.0 not backwards compatible to 2.2.2, which was a huge mistake. So one of the things we learned, we had to do a better job of working with our industry partners, our international partners out there in evolving that SCA standard and bring in a lot more smart people into this whole process and do this so that 4.1 would be something that we could all live with and provide a much better product and architecture out there for everybody. So we've teamed with the Wireless Innovation Forum, of which I think you probably are aware of. A lot of members from industry, obviously, as well as our international partners, part of the Wireless Innovation Forum. And so as a team, we have incorporated a number of all of those recommendations on how to improve 2.2.2 to get to where we are today with 4.1. And I think what I'm looking for now is for folks to try it out. And I know industry already is. I've seen some instantiations basically out there, some products that they've incorporated 4.1 on already. They're not readily available yet, but people have been working it and seeing some real positive effects of upgrading to that particular version. So I would ask you to try it out. Certainly we can address more of your technical type of questions outside of this particular forum as it relates to 4.1.
All right. Anybody else? All right, go get coffee.
All right, thank you all
Thank
very
you.
much. Appreciate it.